Okay, so therefore, the measurement of chord, okay, the measurement of chord OT, okay, so the measurement of chord OT, okay, is going to be equal to 2r sine, okay, theta all over 2. Okay, and once we know the value of r, the radius, and the value of theta, we can find the measurement of the chord that we have here, which is OT. So let's try to apply that formula. Okay, so word problem 4. Georgia is planning to create, okay, a circular garden path in their backyard. To do so, she will need to create a path from points A to D, as shown on the figure on the right. So given that the central angle is 96 degrees and the radius of the circular path is 6 meters, find the measurement of path AD. Okay, so you want to find the measurement of path AD. To do so, okay, so what we're going to do is to use the formula, okay, for finding the measurement of a chord. Okay, so the chord is equal to, okay, 2r sine theta all over 2. Okay, so therefore we have here, since we know that the r here is equal to 6 and the theta is equal to, or the central angle is equal to 96 degrees, so therefore chord AD is equal to 2r sine theta all over 2. Okay, so that's going to give you 2 times 6 sine of 96 divided by 2. Okay, and what's 96 divided by 2, guys? So that's 48. Okay, so this is 12 sine of 48. Okay, so therefore the value of AD, okay, so 12 sine of 48. Okay, so that's going to give us a value of 8.92. Okay, so therefore the value of AD, okay, the measurement of AD is 8.92 meters. So this is the length of the path. Okay, the length of the path AD is equal to 8.92 meters. Okay, so for the fifth problem, Mattia plans to create a circular-shaped supercomputer the size of a first-story building. So the said supercomputer is able to harness enough data power to find the locations of black holes, habitable planets, and find cures for previously thought incurable diseases such as cancer, diabetes, HIV, and more. So the said supercomputer is named Vance, okay, and has a radius of 16 meters, and it creates a chord, okay, at points Vn. Vn is the main entryway and the exit of scientists to observe the supercomputer at work. So if the central angle is 104 degrees and you are one of the scientists who must get to the center of the supercomputer at point A, what is the measurement of AS? Okay, given that AS is a perpendicular bisector of Vn. Okay, so we have here, okay, so let's use white. Okay, so we have here A and then S, so that's the perpendicular bisector that we have here, and we also have V and then N. So our central angle is 104 degrees here, and then we have a radius of 16. Okay, so therefore, okay, to get the measurement of AS, okay, so we can get the measurement of AS here, so using the Pythagorean Theorem. Okay, so before we can use the Pythagorean Theorem, we first have to find the value of Vn. So how can we solve again for Vn? So given that we have here 104 degrees and we have here 16 meters as the radius, okay, so r is equal to 16 meters and Vn is the chord. Okay, so to get the value of this chord, we are going to simply use the formula. Vn is equal to 2r sine of theta all over 2. And theta is equal to 104. So that's going to give us 2 times the radius, which is 16, times sine all over theta, which is 104, all over 2. Okay, so that's going to give us 2 times 16. Okay, 2 times 16, that's going to give us 32, is equal to 32 sine. Okay, and what's 104 divided by 2? 104 divided by 2 is equal to 52. And if we evaluate this, okay, so 32 sine 52, okay, so that's going to give us 25.21. Okay, so therefore, okay, the value of Vn, okay, Vn is equal to 25.21. Okay, so to solve for the value of AS, we simply just have to divide 25.21, okay, I'm sorry, 25.22 by 2. okay, because it's 25.216, and if you round off that one, that's going to give you 25.22. So Vn all over 2 is going to give you 25.22 divided by 2. Sorry, so 25.22 divided by 2, so that's going to give you 12.61. Okay, so 12.61 meters. Okay, and to solve for AS, okay, so to solve for this side measurement, we can use the Pythagorean Theorem. So that's going to give us, so since this is 12.61 and this is 16 meters, okay, and 16 meters is the hypotenuse, so that's going to give us AN squared is equal to AS squared plus, okay, plus SN squared. And we know that AN squared is equal to 16, and we know that SN squared is equal to 12.61 meters, okay, or squared. Okay, so we just have to square that. We just need to find the value of AS. So AS squared, okay, is going to be equal to, okay, 16 squared minus 12.61 squared. And what's 16 squared minus 12.61 squared? Okay, so that's going to give you 96.9879. If we try to find the square root of that value, okay, so that's going to give us a value of, okay, that's going to give us a value of, wait a minute, this is AN, okay, AN, okay, so AN, okay, AN is equal to the square root of 96.9879, and the square root of that is equal to 9.85. Okay, so there you go. The area of AS, okay, wait a minute, so, oh yeah, this is AS na pala. Okay, so this is AS and this is AS. So therefore, the area of AS, okay, the value of AS, okay, the value of AS, okay, so the line segment AS here is equal to 9.85 meters. So we solved it using the chord, okay, finding the measurement of the chord using this formula. And then after we find Vn, okay, after we found Vn and also Sn, we've tried to find the value of Sn, and after finding the value of Sn, okay, we used the Pythagorean Theorem, and we found that the value of AS is equal to 9.85 meters using the Pythagorean Theorem, because 16 squared minus 12.61 squared is equal to 96.9879, and if you find the square root of that value, that's going to give you 9.85 meters. Okay. And then for our sixth problem here, so Dr. Santos wants to determine the length of a scratch found on the head of his stethoscope. So given that the scratch is marked as segment OR, okay, or line B, find the value given that GH is equal to 15 millimeters and TH is 12 millimeters. For this problem, guys, okay, we need to find the value of line B. Okay, so we need to find the value of line B. So we can see here, guys, okay, we can see here that TH, so TH is equidistant, okay? Okay, so they're equidistant, these points here are equidistant to each other. TH, okay, let's say this is point X. Okay, so TH is equidistant to point X because TH is equal to TX. So this is not the radius, so this is just, okay, a segment found in the circle. So therefore, since they are, what do you call this? So since they are congruent to each other, okay, using the circle chord theorem, okay, let's try to go back using the circle chord theorem 2b. Congruent chords are equidistant from the center, and since chords OR and GE are both equidistant from the center of circle T, okay, so therefore GE, okay, equidistant meaning that they have both the same values, okay, 12 is equal to 12, the distance from the center. So therefore GE must be equal to OR, and we know that GE is equal to GH plus HE using the segment addition postulate, and therefore GE is equal to 15 plus 15, and therefore GE is equal to 30. And also that must mean that OR is equal to 30 millimeters. Okay, so this is the length of the scratch found on the stethoscope of the Professor are the doctor that we have here. So OR, okay, OR is equal to 30 millimeters. Okay. Okay, guys, for this one, let's try to prove a theorem, okay, about the chords of a circle. Prove that the chords of a circle are equidistant from the center. Okay, that are equidistant from the center, we have to prove that they are congruent. So that was the problem that we solved a while ago. So let's try to prove this theorem. So for this one, we can write here given, okay, so OE, okay, so circle O with OE and EF, OE and EF are congruent. And we have here OE, AB, and OB, AB are perpendicular. And also we have OF and CD are perpendicular. So those are all of our givens. Okay, so we have to prove that AB is congruent to CD. So we can simply write here number 1 given. Okay, and for number 2, okay, for number 2 we can state that, okay, so for number 2 we can state that all of the radius on the circle are congruent. So we have here OA, OB, OC, and OD are congruent to each other. Okay, so that's using the property of a circle. Okay, all radii of a circle are congruent. Okay, and also, okay, we're going to a triangle congruence postulate here. Okay, so let's try to notice. We can notice that AEO and A and CFO are right angles. So we can write here, okay, angles AEO and CFO are right angles. And therefore, if they are right angles, okay, so if they are right angles, therefore we can say that they are right angles because what they call this, perpendicular bisectors produce right angles. Okay, so there you go. Okay, and therefore we can say that, okay, so we can say here that triangle, okay, number 4, triangles AEO and CFO are congruent to each other because they are right triangles. And also, since they are right triangles, we can use a congruence postulate specifically for right triangles, and that's going to be the hypotenuse leg right triangle congruence theorem, because we said that they have congruent sides because they have been bisected, and also, okay, the radii are congruent to each other. And therefore, since we have two congruent triangles there, we can say that two right triangles that are congruent, we can say that angles A and C are congruent, okay, using CP, CTC. And we can also say for number 6, okay, we can say for number 6 that angles C and D are congruent, and angles A and B are congruent also, using the isosceles triangle theorem. Okay, so we can write here isosceles triangle theorem. Okay, so therefore for number 7, we can say that angles B and D are congruent to each other. Okay, so they are congruent to each other using the transitive property of congruence. Okay, transitive property of congruence or equality. Okay, and therefore, okay, so if we have here, that's for number 7, we can say for number 8, okay, we can say for number 8 that triangles AOB and COD are congruent to each other. Okay, so we can state that. Okay, we can state that using the SAS. Okay, number 8, SAS triangle congruence postulate. Okay, before this, okay, we can say here at 7.1 that angles AOB and COD are congruent using the vertical angle theorem. Okay, so we can write here vertical angle theorem for 7.1. Vertical angles are congruent. Okay, and we can lastly say here for number 9 that AB is congruent to CD using CP, CTC. And therefore, we will have proven our theorem, the chords equidistant from the